Hello and welcome to the Tanzu Kubernetes Grid guest cluster protection demo. So in this demo, we'll have a look at how we create the supervisor cluster, supervisor namespace, and then protect the guest clusters on top of them. So here is the supervisor cluster that you can see. So in a fresh environment, you can add a cluster, go to workload management, and select all the necessary resources such as storage, network, and other configuration details, and set up your supervisor cluster. So as you can see, after the supervisor cluster is running, you would see the running status along with the IP address. And here you would create your supervisor namespaces. So at first you would have to create a Velero Supervisor namespace so that you can install Velero plugin on top of that, which will be used by PPDM for protection purposes. Also, in the supervisor cluster, you would be able to see the services that are running for supervisor. So an additional Velero operator that is available with vSphere 7.0 U1 Update 1C. So you should be able to go ahead and select that operator and enable it. So in this demo, we'll see that it's already enabled. Now, if we go back to workload management, we would see that we'd also have to create a supervisor namespace. In this demo, it's test ns1. So you can just go ahead and create a new namespace and provide its DNS compliant name, and that's it. As soon as you have your supervisor namespace created, you should be able to get into the CLI for a vSphere and then create your guest clusters. So this is your supervisor namespace. And here are your supervisor control plane VMs. So we can get into any one of those VMs and get the IP address assigned to it by workload management and be able to connect to the vSphere Kubernetes CLI for TKG. So if we get into the URL bar and use that IP address, we get into this page where we can download the plugins and also connect to the CLI and run the kube control commands for TKG clusters and create the guest clusters on top of the supervisor namespace. So in this demo, we have already created two guest clusters inside the supervisor namespace, namely TKG cluster 01 and 02. So as you can see here, we have one control plane for each of the guest clusters and 3 worker VMs. So all of these configuration details are provided in the YAML file that you use while creating your guest cluster. In the supervisor namespace, you should also be able to check the storage section where you can see the storage policies that the supervisor is mapped to, the config map files, secrets, and the persistent volume claims that have been used by the different pods. In the guest clusters, these persistent volume claims are provided in a paravirtualized manner, and we'll protect those paravirtualized persistent volumes using our new solution with PPDM. So here are the two TKG clusters. And now if we go to the vSphere CLI for Kubernetes TKG and check the contexts, we should be able to see a bunch of IP addresses here. So as you can see here, 129 corresponds to the supervisor cluster IP address. And inside test NS1, we see TKG cluster 01 and 02, our two guest clusters. And those two guest clusters have also an associated IP address, 130 and 131. Right, so now here is the PPDM interface where we can add protection storage for sending the backup data. And here at first you would have to add the vCenter as an asset source. This vCenter should be the one that's hosting the TKG clusters. And then we should be able to see all the assets, whether that be supervisor control plane VMs or worker VMs listed in the virtual machine assets that can be protected in a VM image level backup as well. Now to protect it in the Kubernetes fashion, we'll go ahead and add the guest clusters to the Kubernetes section. So here we'd have to use the toggle option to make sure and enable the Tanzu cluster is set. And then we would select the proper vCenter the guest cluster is part of, then use the IP address associated with the guest cluster and the service account tokens to integrate the guest clusters with PPDM. And as soon as we do that, we'll be able to see all the Kubernetes namespaces available as assets for protection. So here we'll go ahead and filter the namespace that we'll be protecting in this demo. It's DKKRS demo and it belongs to the cluster guest cluster 131. So now if we go back to the vSphere CLI, we should be able to see all the namespaces here for that particular guest cluster. So we see the DKKRS demo that is the one that we are going to protect. And since the guest clusters are already integrated with PPDM, so we see the PowerProtect and the Velero PPDM namespaces as well. So let's have a look at the pods inside the PowerProtect and the Velero PPDM namespaces. So in the PowerProtect namespace, we see the PowerProtect controller pod running. So there is no change here with respect to our older architecture. However, in the Velero PPDM namespace, we see an extra pod named backup driver. This backup driver interfaces and helps protect and take snapshot and delete snapshots for paravirtualized CSI volumes for the guest cluster. Also, as a prerequisite for protecting TKG guest clusters, we need to add vproxies as data movers. So we'll be able to provide all the details that is needed to deploy a vproxy from PPDM and then choose Kubernetes as the supported protection type. Also, we'll be able to utilize and exploit the hot add feature that vproxy provides if the particular vproxy is deployed in the host and has data store privileges that the TKG clusters are using. This will actually enhance the performance for data backups as well. So now let's go ahead and create a protection policy and protect the namespace that we saw before. So here we provide the policy name, select the type as Kubernetes, and next. So here we would select crash consistent, and we will search for the particular namespace that we are going to protect in this demo, which is DK demo. Also, as part of managing exclusions, if there are multiple PVCs and we want to protect only a few of them, we can do that from the PPDM UI. So let's have a look at the pods and PVCs in the application namespace. So here we see that there is one pod running and there is one PVC that's bound to that pod. Now let's exec into the pod and check the data. so that when we restore, we can verify that all the data is restored along with the mount points. All right, so now let's list the mount points that's associated with this pod. Here is the mount point. So now let's have a look at the detail inside the mount points. So here's the data that we'll protect and restore in this demo. Now let's exit from the pod interface and check the storage classes. So we support csi.vsphere.vmware.com CSI driver. And as you can see that our PVCs are bound to the storage class with the same CSI driver provisioner. Now we'll go ahead and create a backup schedule to protect the guest clusters. Here we are setting the recurrence and the retention for backup stage. With 19.7, we can also use existing storage units for particular policies as well. And these storage units are supposed to be created from the same PPDM that we are using. However, in this demo, we'll create a new storage unit for this policy. Now you can see that the policy config jobs have begun. So we'll wait for the config jobs to complete. Now it's completed, so we can go ahead and go to protection policies and start an on-demand backup or on-demand protection for the selected namespace asset. So we'll be starting a full backup for the selected asset. Here you can see that the protection has started. So let's go inside the protection job and have a look at the details. Now going back to the Kubernetes CLI, let's have a look at the pods inside the application namespace that we are protecting. We just see the application pod that's running in the namespace. So no cproxy pods are created. And as you can see here, the container volumes and the virtual disks are being attached to vproxy. The backup job is now in progress, and we'll wait for the backup job to complete successfully. Please review that the backup job has completed successfully and a few details on the data transfer, average throughput, and the other parameters have been updated in the job description. Also, we'll be able to verify the vproxy that has been reserved for this particular backup job and the task ID associated with it. All the other details will also be available in the backup job details. All right, now let's go to protection policy and add a replication stage to that particular policy as well. So here we have to select the primary backup stage and click on replicate and set the replication schedule so that the backup copies can be replicated to a data domain in another site. The same new and existing usage of storage units can be used for replication stages as well. So we'll wait for the replication config to complete. So now you can see that the configuration job for replication has completed successfully. Now we can go ahead and start an on-demand replication job as well. Here we just have to select replicate now and the replication storage where we want the backup copies to be replicated to. The replication job has been initiated now. We can have a look at the details of the replication job as well. As you can see that the replication job completed successfully and the other details pop out in the details section as well. Now we can go ahead and recover our namespace asset from the PPDM user interface itself. So here we can search for the application namespace that we were protecting. So here is the TME Pacific protection policy that we use to protect that namespace asset. So we can view the copies, whether that be for the primary backup or for the replica. We can restore from either primary backup or the replica copy. But in this demo, we'll choose the primary backup copy to be restored from. Another option is to restore to an alternate cluster as well. So you would have to choose between the available guest clusters that have been added that can be part of a different supervisor cluster as well. But in this demo, we'll choose to restore to the original cluster and restore the namespace and PVCs and restore to a new namespace. So here we provide the name of the new namespace that will be created in the guest cluster, namely TME Pacific Restore. And here is the PVC that we are going to restore. You can review the restore summary and then we click on restore. This initiates the restore job. As you can see that the restore job is queued now and is now in running state. So let's go back to the Kubernetes cluster CLI and get the namespaces. So now we see that a new namespace named TME Pacific Restore, which is 21 seconds old, has been created. So let's have a look at the pods and PVCs inside it. So since the restore has not completed, we don't see any resources. And as you can see that the virtual disks and the container volumes are being attached to the new namespace. Now we will wait for the restore to complete successfully. Now you can see that the restore job has completed successfully. We can also look into the job details for the restore job as well. And as in a protection job, even for a restore job, you will be able to verify the vProxy that has been reserved for this particular operation. Now, if we go back to the Kubernetes CLI, we should be able to see the pods and PVCs inside the new TME Pacific Restore namespace. So now we can get inside the pod and verify that the data has been restored successfully. So here we are execing inside the pod. Now we'll have a look at the mount point. And here is the mount point that's available. And now we can verify the data inside the mount point. And that's it. Restore completed successfully. Thanks for watching this demo.